Hey guys, I'm going to go ahead and go over another video. This video is going to be talking about the product rule. So let's go ahead and get started. Just real quick, the formula that I'd given you guys before is the derivative of any two functions u and v with respect to x is equal to, u and v are functions that are being multiplied to each other, okay? V times u prime plus u times v prime. And these can be alternated because it's like saying 3 plus 2 is the same thing as 2 plus 3. Okay, they're commutative, so it can be switched on this one. All right, so the first one is y is equal to 6x sine of x. And in order for you to take the derivative, you have to recognize that there's two functions being multiplied to each other, 6x and sine x. So if you follow this formula, we can take the derivative of 6x, which is 6, times the original, which is the second, plus the first, 6x, times the derivative of the second, which is cosine of x. And that's pretty much your derivative. There's different variations. You can write this by factoring some stuff out, but we'll leave that for later. All right, the next problem is if you have this function g of x is equal to negative 2 cosine of x times 3x cubed minus 5x plus 7, find the derivative of g. So once again, it's going to be the product rule because you have one function times another. So the derivative of this is going to be positive sine of x because the derivative of cosine is negative sine times that negative is a positive. And then times the original, minus 5x plus 7. And then plus, rewrite the first, so minus 2 cosine of x times the derivative of the second, which is 9x squared minus 5. And once again, you're able to factor out a 2, okay? Or you can basically just distribute, but this is the derivative, okay? All right, the next one on this note card, it gives you a table. It says in the table, r of x and t of x are differentiable functions. Find the equation for the line tangent to q of x at x equals negative 3 if q of x equals to r of x times t of x. And you guys will be able to see it with the attachment that goes along with this video, okay? All right, so we have, we want to find the derivative of q of x at x equals negative 3 so that we can get the slope. So first of all, we want to know a tangent line, right? So we need a point and a slope, okay? And of the point, we already have the x value. So we just need the y value and the slope, all right? We also have this formula that q of x is equal to r of x times t of x, okay? Let's try to find the slope first. So if we take the derivative of this q of x, we know that we're going to use a product rule because there's two functions being multiplied to each other. So it'd be r prime of x times t of x plus r of x times t prime of x. So this is the formula we're going to use, okay? And we can plug in negative 3. So r prime of negative 3 times t of negative 3 plus r of negative 3 times t prime of negative 3, okay? So all we have to do is just fill in these numbers based on what the table's telling us, okay? So here we know that r prime of 3 is negative 2, and t of negative 3 is 2, plus r of negative 3 is negative 4, times t prime of negative 3 is 3, okay? So we just multiply these out. Sorry, that's a minus sign, minus 12, and that's a negative 16. So now we have the slope. Now to get our y value, we plug it back into the original. Okay, so q of negative 3 is equal to r of negative 3 times t of negative 3. So once again, r of negative 3 is negative 4, and t of negative 3 is 2, and we end up getting negative 8. Okay, so that's negative 8 here. So that means now we can find the equation of the line. So it's y plus 8 is equal to negative 16 times x plus 3. And that's the equation of the line. Okay. All right, the last one here is number 4. And it's saying for the values of x that are between pi and 2 pi, sorry, it's not including it, so we're going to put parentheses. So between that interval, where the tangent line to the graph of, so we want to find the tangent line that's horizontal, all the horizontal tangent lines that are within this interval for this function. Okay, so once again, If you want to find a tangent line that's horizontal, we know that horizontal tangents have a slope of 0. So we first need to take the derivative and set that equal to 0, okay? So when we take the derivative, we need to use a product rule. So the derivative of sine is cosine times the second, which is cosine again, plus the derivative, we write the first one again, so it's sine of x, times the derivative of cosine is a negative sine of x. So we end up getting cosine squared x minus sine squared x, okay? And we're going to set that equal to 0. So what I like to do is I like to, in this instance, set these, move this over here to this side, so it becomes a positive sine squared. And we basically have to figure out when is sine and cosine equal to each other. Now, if you remember the unit circle, in the unit circle, we know that sine and cosine are equal to each other at pi over 4 and at 5 pi over 4 because they both have the same sign. But because it's being squared, they're also going to be equal to at 3 pi over 4 and 7 pi over 4 because although they have different signs, they have the same number. So we're going to say that x is equal to pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. Okay, and just to let you know that the number at pi over 4 is square root of 2 over 2, square root of 2 over 2. So cosine and sine are both the same. So we have the tangent line. We know where they're located now. So we found the x values in which where the line that's horizontal, the tangent line that's horizontal to this graph, are at these specific points here. Okay.